Okay, today is going to be kind of an interesting lesson. I'm going to move this, wrong thing. I'm going to minimize this and move this up. Okay, a couple things. First off, I was listening to a podcast the other day, and they brought up this topic that reminded me of some stuff. All-female crew, the Maiden, sailed around the world and into history. This woman named Tracy Edwards started sailing in the 1980s. And what's amazing about it is that she, on I believe her second race in 1985-86, she formed an all-female crew. And that female crew, I believe, got second place in this white bread around the world sailing race. And that reminded me way back when I saw something about sailing around the world the wrong way. And I was wondering back then, this is when I first started teaching, so this is the mid-90s, what is the round the world the wrong way? Now, you guys can see the map up here. Let's go to that map, because around the world the wrong way, what we're talking about is ocean currents, right? And so ocean currents, what we have is the world. Now, I'm going to find my blue marker and red marker. Okay, and it doesn't show up very well on this map, but we'll try and work with it, okay? Because I'm doing warm ocean currents and cold ocean currents. Now, the Earth spins that direction, okay? So the Earth is spinning that direction. And whenever you have something that is going that direction, okay, if I sit something on here like my dinosaur, I move it, he should fall that way, but I stopped it, so yeah. But if I started moving like he'll fall over, right? So the water around the equator wants to move that direction. And the water around the equator is warm. So the equator is right at 0. Here's my black marker, right at 0. Okay, there's the equator. And so at the equator, you get ocean currents that start to move that direction. And that is a red color marker. Okay, here they flow this direction. So when it reaches a landmass, they will bend toward the poles around that landmass. Okay, and they will flow up here. Okay, so around the equator, warm currents flow east to west around the equator. And I already will need a different piece of paper. Okay, so warm currents flow east to west around the equator. So you get these ocean currents that will flow around the equator and then toward the poles. And I get that there too. Around the equator. Okay. And then when they hit that land, it will bend toward the poles. Okay, here's the EAC. You guys have probably heard about that. That is the current that Finding Nemo happens in, right? Now here, you have a warm current that comes in and it gets kind of trapped in the Bay of Bengal and the Arabian Sea. Okay, so typically that is your warm current. Okay, now then you're going to hold another piece of paper here. I'll write this with a regular pen. The warm currents flow east to west around the equator. Warm currents also flow from the equator toward the poles on the east coast. Okay, so second thing you need, warm currents flow from the equator toward the poles on the east coast. Now, cold currents. Cold currents are a little bit different than warm currents. Cold currents will flow along the west coast toward the equator. Okay. Oh, another story I can tell you guys really quickly in a minute. Just a minute, not quite yet. Okay, cold currents. And this is my blue pen, so I got and these are just major currents. We're not going to go through every single current they have. But the cold currents flow from the poles toward the equator on the west coast. Okay, so essentially you get clockwise currents in the north, clockwise, and counterclockwise currents in the south. Now there's a really cool story, and there's no reason why I'm drawing these red and blue here. In fact, I should have done it black. I might do it in black if my eraser still works here. Not, my eraser's not working. But there's a really cool story. Ernest Shackleton, he was a polar explorer during World War I, 1914. He was a guy that tried to sail or tried to go to the South Pole early on. Okay, but he took a ship down into the Weddell Sea, I believe. And when they took the ship was called the Endeavour. Wait, was it the Endeavour? I think it was. Endeavour. But the ship got stuck in the ice down here, and it got broken up. And he took his men, his crew, up to a little island up here. They walked across the ice, got there while the ship sank. Now, when they got there, all the men were alive. The ship sank slowly. I think, and they had dogs, dog teams, dog sleds. They took those up there too. And the men started to live on, I think, penguins and seals and dog meat. But they also had some supplies that they kept themselves alive with. Now, he could have sailed from, hang on one second. Okay, sorry about that. Had a little interruption, but that's okay. So Shackleton had his men on this island. Let me go back to the main camera so we can see what's going on. Elephant Island. Let me blow that up too. What's really cool, and this is in the book called South. So if you ever want to look at that book, it's awesome. But instead of sailing for help, he had a little lifeboat. They drove their lifeboat up to the island with themselves. Instead of sailing across that strait, he knew the ocean currents. Okay, and across the Southern Ocean, we have an ocean current that is uninterrupted. So you get crazy currents there. You can get 60, 70, 80-foot waves. So instead of sailing that way, he knew the ocean currents. And he sailed to the South Sandwich Islands. Maybe it was New South Georgia. I think it was, oh man, I don't remember. I have to look it up again. So he sailed, I think it was 800 miles in a lifeboat with two other guys. And then he walked across the island to the only town on the other side, which was a whaling station, and told them that he had his crew shipwrecked on Elephant Island, and they needed help. And so he was able to get other men from Chile down, and they rescued the people. And it was about a year or two that these guys were shipwrecked on a little island out in Antarctica. So ocean currents. Ocean currents do influence your climates too. This current up here, okay, and then we have minor currents in these small seas and stuff. But this ocean current right here, okay, these warm currents, this will produce a hurricane, okay? And so these hurricanes will track and hit the United States. These in the southern hemisphere, they spin the other direction. Because of the Coriolis force, okay, and that's the same direction. See how hard it is. So they spin the other direction, and then they hit right like that, okay. And in the southern oceans, they're called cyclones. In the Pacific, they are called typhoons, okay. And here, only in the Americas, they are called hurricanes. That's a Native American word, okay. So, ocean currents, very important. They will influence your climates. These warm currents will keep the northern parts of the continent very warm, okay? I've been to a place in Scotland where they have palm trees growing on the coast up here. Not very many, but they do have some. Okay, Alaska is fairly warm because of that Kyushu current that comes into the Gulf of Alaska. The East Coast is a lot colder. If you've ever noticed the weather, okay, the weather on the East Coast, if you watch weather, you'll see we get snow down into Washington, D.C. every year. Okay, Maine, it's further south than Washington State, but Maine has extremely cold winters because of the ocean currents and how things flow through here. And it's also based on wind belts. So the wind belts, I'll show you those too. Okay, over here, I was in Vladivostok right there. That's about the same latitude as Portland, Oregon. And in Vladivostok, they will get down to 50 below zero in the wintertime. Okay, very, very cold. I also lived in Alaska, up here in Anchorage. And the coldest I ever saw it there was about 40 below. So it was warmer than Vladivostok. I will give you another lecture on, we did wind belts, we did ocean currents. Next will be, rain shadow. So those are the ones you can look at. Wind belt lectures, rain shadow, and now ocean currents, okay? And what we're building toward is climates, okay? We want to see why the climates of the world look somewhat like that, okay? And we'll run through this later on, but I'll run through why climates look the way they do. Talk to you later.